students, in our previous class we learned about the concept of resistance. In this session we will see the factors affecting the resistance of a conductor. What are the factors on which the resistance of a conductor depends? Resistance R is directly proportional to the length of the conductor. That means if the length is more, resistance will be more, and if the length is less, the resistance will be less. R is directly proportional to length. Say L be the length of this conductor. This conductor is shorter in length when compared with this one. Among these two conductors, which one will be having more resistance? The one which is longer will be having more resistance because resistance is directly proportional to the length of the conductor. We know that the resistance occurs due to the collision of free electrons with the positive ions. If the length is more, the collisions will be also more. That is why resistance is more for the longer conductor. Resistance of a conductor is inversely proportional to the area of cross section of the conductor, where A represents the area of cross section. R is inversely proportional to area. Look at these two conductors. This thin conductor will be having more resistance when compared with this thick conductor. For this thin conductor, area of cross section is less and hence R will be more. For this thick conductor, area of cross section is more and resistance will be less. Here the electrons are getting a larger area to flow and hence the resistance will be less. Resistance also depends on the nature of the material of the conductor. For example, say this be a nichrome wire and let this be a copper wire. If you take equal length and equal area of cross section from these two wires, the resistance will not be the same. It depends on the nature of the material. For the nichrome wire, it will be different, and for the copper wire, the resistance value will be different. Resistance depends on the nature of the material. Resistance of a conductor is directly proportional to the length of the conductor and inversely proportional to the area of cross section of the conductor. It also depends on the nature of the material of the wire. R is proportional to L by A. Combining these two, you can write like this. R is proportional to L by A. Now we can replace this proportionality sign with an is equal to sign. R is equal to rho L by A, where rho is the proportionality constant which depends on the nature of the material. R is proportional to L by A. R is equal to rho L by A, where rho is the proportionality constant, which is called resistivity or specific resistance. Rho is the constant of proportionality and is called resistivity or specific resistance of the material. It is different for different materials. R is equal to rho L by A, where rho is the specific resistance. What is rho? Rho L is equal to RA and rho is equal to RA by L. And if you want to define this resistivity or specific resistance rho, how will you define? Make this A to unity and L to unity. If A is equal to 1 and L is equal to 1, rho will be R. That is how you define the resistivity rho. Rho is equal to RA by L. Specific resistance of a material is the resistance of the wire of that material of unit length and unit area of cross section. Make this A to 1 and L to be 1. Then you can say rho is equal to R. Specific resistance of the material is the resistance of the wire of that material of unit length and unit area of cross section. What will be the SI unit for this rho? Rho is equal to RA by L. What is the unit of R resistance? It is ohm. Area, it is meter squared. For length, it is meters. Meter and meter get cancelled. Therefore, the SI unit for rho is ohm meter. SI unit is ohm meter for resistivity. This table shows you the resistivity of some substances at 20 degree Celsius. For example, silver, the resistivity is this value. For aluminium, it is this value, and so on. For the conductors, it is in the range of 10 raised to minus 8, which means it is very low. The resistivity is very low for conductors. Whereas if you look into the insulators, it is in the range of 10 raised to 14, 10 raised to 16, which is very high. The resistivity is very high for insulators. You know, conductors are good conductors are conducting electricity, whereas insulators are poor conductors of electricity. You don't have to learn these values by heart. These values will be given in the question for doing the numericals. This table is just a reference to understand that for different materials, the resistivity value will be different. In this session, we learned about the various factors affecting the resistance. Resistance is directly proportional to the length, inversely proportional to the area of cross section. It also depends on the nature of the material. R is equal to rho L by A, where rho is called resistivity. Resistivity rho is equal to RA by L. See you in the next class.